Following examples come from Lesson 2.4, Graphs Can Be Misleading. Example 1. The population of country A is twice as large as the population of country B. True or false? If images are used to represent populations, both the height and the width of the image for country A should be twice as large as the height and the width for the image of country B. Right? Now, let's take a very simple example of rectangles. Okay? If we have a rectangle here and another rectangle, let's say, right here. Alright? And let's call this first one country A, and then the second one is going to be country B. Okay? Alright, so the population of country A is twice as large as the population of country B, and we want to know if, do I need to double both the height and the length in order to have twice the area that I have in country B over here. Alright, so let's just suppose that country B has a width of 4. That would make the width over here of country A be 8 if I'm supposed to double it. And let's say that the height on country B is 5, which would mean that the height on country A over here would have to be 10 if I'm going to double that. Okay? Alright, the area formula for a rectangle is the base times the height. So for country A, the area would be 10 times 8, or 80 square units. And then for B, the area would be 4 times 5, or 20 square units. And so, since our area here, A, is not twice as large as the area B down here, the 20, it's actually 4 times as large, our statement up here is in fact false. We don't need to increase the size of both the length and the width. In fact, we will increase either the size of the length or the width, and that would give me an area that's twice as large. Example 2. If the baseline for a bar graph of a time series plot is not at 0, then the differences may appear to be smaller or larger than they actually are, and you have to pick smaller or larger. Well, if you're looking at a graph, and if you are not starting at 0, well, if you are starting at 0, we can have something that would look kind of like this right here. You know, a little bit of an upward trend there, okay? But if we drew the same graph and we started, let's say this one right here is 15. So let's say we started our time at 15, then our graph is actually going to stretch these things out, and it's going to make the differences look a little bit exaggerated, as you can see. And so what happens is we're actually zooming in on this area right here, kind of blowing it up. So any differences that happen are going to in fact be larger than what they actually are. I'm sorry, I guess I mean they're going to appear to be larger than they actually are.